So we had mentioned the stages that we're going to be working with in the development of a database system or an information system. And we'd already talked about the analysis stage. And so in the analysis stage, we want to gather information from primary or secondary sources for us to be able to understand the system, the process, or the problem. That's the purpose of the analysis stage, is to understand the situation, the process, the system, the problem, and have enough inputs to be able to now start designing the solution. And remember that in the second stage, which is the design stage, we're going to try to use the information from the analysis stage to be able to create a conceptual model or representation of the solution. When I'm saying it's conceptual, it means that we haven't implemented it yet. We're going to be using engineering tools and resources to be able to create this concept or this conceptual model of the solution. And we're going to need to have done a very good analysis to be able to extract that. Now, in the design stage, going back to the discussion or the conversation we were having last session with Marco, that we were talking about the five things that a good engineer should be able to do and should have in his or her toolkit, tool belt. And we were talking about this situation where I had given Jesus requirements for a water bottle, and Jesus does a design, and then Jesus gives it to Marco to do the manufacturing, but there has to be a continuous loop of communication between those areas. And that doesn't normally or by default occur. So one thing that's important in the design stage is that these stages should be iterative and should create a sort of loop. Meaning, if we're in the design stage, there might be issues or things that come up where we might have to go back to the analysis stage to gather more information. The same thing happens in the other stages. In the development stage, we might notice in the development stage that part of the design can't be implemented as such or doesn't work correctly. So we have to go back to the design stage. And even in the testing and deployment stages, in the testing stage, we might notice that something doesn't work or something isn't working correctly. So we have to go back to the design stage and redeploy or redevelop, I'm sorry. And so what I'm trying to transmit with this is that these stages are sequential, but think of them as sort of an iterative process. So we're going like this, but at the same time, we're kind of doing this, right? We're kind of doing loops where we go back to the previous stages if necessary. I think it's very dangerous in the development of a system to just go linearly and take everything that's done and just go forward and say, you know what, we're done. Because in the end, we might get to this stage here, to the deployment and implementation, and notice that everything's wrong. And we don't want to notice here, because if we notice here, then all of the rest of the work we've done is going to be meaningless. And so the iterative approach, I think, is a sound one. Okay. Does that make sense, everybody? Are we okay up to this point? Okay, good. Good. Let's do an exercise here and see if you guys are awake. Alejandro, give me one of the 5 things that an engineer that's worth their any engineer that's worth their degree should be able to have. Give me one of the 5 things.
Analyze.
Analyze. Perfect. Thank you, Alejandro. Anna, give me another one.
Improve.
Improve. Perfect. You don't have to say them in order, because remember, we mentioned You don't necessarily have to be experts in the 5 things. You need to be able to do the 5 things, and you're not necessarily going to be doing them always sequentially. Marco, go ahead. Give me another one.
Implement.
Implement, deploy. Perfect. We've got 3. Let's see. Fernanda, give me another one. There's 2 left.
Optimize.
Optimize. Remember, one thing is to improve something. That means to make it better. Another thing is to make it the best possible. It's optimization. And we're missing one, which is actually what we're going to be we're talking about today. And it's in a box there on the screen. Luis Espinosa, the shade, crime fighting. What's the last one that we're missing?
Design.
Design. It starts with a D and finishes with design. So yeah, design. So remember those things, guys. I'm gonna be asking you. So, and remember, if anybody has a question, jump in. Please jump in. So right now we're gonna be talking about the design phase. Oh, by the way, I just want to be clear about this. This is freshman level course, right? It's a first year course in data analysis and organization for industrial engineering, where you guys aren't experts in the development of information systems. So we're going to be talking about these 5 stages with a focus on database systems in the course very quickly, right? But you could have one complete course about each of these things. You could have one complete course that just focuses on analysis, one complete course that just focuses on design, another. So right now we're going quickly through each of them because that's the purpose of the course. The idea is for you to know these things and be able to start incorporating them in your toolkit. But we could stay the whole semester in stage 1 if we wanted to. And you're going to be taking courses further on in industrial engineering, where you're going to be doing a lot of analysis. That your engineering methods courses, for example, you're going to be doing a lot of analysis. We could focus the whole semester on one of these, but we're going through them quickly so you understand them. Okay. So now we're going to be talking about design. And remember, right now, design again, and remember that I'm mentioning these, and these aren't on the screen on the PowerPoints, and they're going to be probably questions on the exam. These aren't written down specifically in the PowerPoints, but I've been mentioning them a lot. So how would we define analysis? Again, analysis is to gather information from primary and secondary sources to be able to understand the problem, the system, or the process that we're going to be addressing. I'm sorry. How would I define design? Well, design is to be able to create the conceptual model of the solution to the situation, problem, system, or process using engineering tools and methodologies based upon the results of the analysis stage. That would be the definition of a design stage. Okay. By the way, those 2 definitions that I just gave, they apply to any type of analysis and design. They're not necessarily definitions just for information systems. Okay. But right now we're all going to be focusing on information systems and databases. Okay. And so let's talk a little bit about the design stage. Well, what are the components of the design? Or what do we have to create conceptually? Well, first off, we have to create the database. And remember that we talked about this. There's a difference between a database and a list. A list is just going to be a bunch of things, values that are just placed somewhere. The difference between that and it's just data that's going to be there. The difference between a list and a database is that the database is going to have the data, but it's going to be organized in a certain structure, and the structures that are inherently are inherently part of the database are going to establish relationships between things. That's going to be really important. So we need to design that structure. This is going to be a lot of what we're going to be focusing on right now in this section. The design of the database, the structure of the database. And again, using engineering tools and methodologies. we have to do some other things as well. We have to be able to develop the interface. What is the interface? It's whatever is interacting. So the database is going to be here. And then I'm the user on the other side. There has to be something in the middle where I am interacting. And that's called an interface. Okay, that's called an interface. We are going to be having to generate reports, which is basically what information we're going to present that's extracted from the database and how we're going to present it. And the queries, meaning how, remember what query meant? Can somebody tell me what the word query means? This is English. This isn't. It's a question, exactly. Query means question. So when information systems, we talk about queries. Queries is when we ask the database for something. So in the database, I have the information of all the students, professors, and courses that are being taught at CETIS. I'm going to ask the database, give me the list of students that are taking the data analysis and organization course with Professor Sosa. That's a query. That's a question that I'm going to ask the database, and the database is going to provide me that information, that data, and I'm going to organize it as to how to present it in a report. So these are some of the basic components that our design is going to have. And that's what we're going to be focusing on in this section. Remember, any questions, just either raise your hands or jump in. I'm saying raise your hands or jump in because depending on how I have my Zoom screen, maybe I'm not able to see you if you raise your hands. So everything's linked. A good design, in theory, should be the product of a good analysis. If I do my analysis correctly, then I'm going to have good inputs to do a good design. If my analysis is trash, I'm using trash as an input to do a conceptual model of the solution. So what's going to come out of that? Trash is going to come out of that. Remember that, you guys. If I don't do a good analysis, the result of the analysis is going to be trash. I want to use another word, but I want to be politically correct, and I'm not going to use. I'm going to use the word trash. It's going to be trash. And if I give trash as an input for a design, the design is probably going to be trash as well. And if the result of the design is trash, when I develop the system, I'm going to be developing trash. And in the end, what am I going to be implementing? Trash. And we don't want that. And by the way, you guys, do this. I want you guys to have this focus in this course. Think about yourselves as users. You are users, right? You're users of systems. Is what I'm saying, does it make sense for you as users? Can somebody give me an example of a system or a process or whatever that you have experienced as a user that kind of frustrated you because it didn't work correctly? Can anybody give me an example?
I set this up in the morning.
Could you say that again, Miguel, please?
The set is up in the morning.
The set is up in the morning. Thank you, Miguel. By the way, let's stay with that a little bit. Remember, you guys, please turn on your cameras if you participate, just so you pop up. That's a good example, Miguel. Let's stay with that. Because it's an interesting as a perspective as a user. I've used the CETIS app, but usually I arrive at CETIS at around a little bit before 8 a.m. after I leave my daughter at school. And usually I fill in the app in the morning at around 7:30. And I've actually haven't had a problem with that. But I have heard that it's a bit different and chaotic earlier in the morning. So expand a little bit on that, Miguel. As a user, what experience have you had with that has not necessarily been positive with the app?
It doesn't let me enter the, I don't know, how do you call it?
The questionnaire, the survey?
Yeah, the survey.
So you're trying to fill it out and it's slow. It's slow. So let's stay with that. Well, thank you, Miguel. That's a very good example. The rest of you, reactions. Have you had that problem as well? Who has had that problem with the app? Anybody else? A few of you have. Okay, Fernando raised
I
her
have
hand,
to.
Leo, Jesus as well. So Jesus, you've had that problem that you're trying to fill it in and it's slow and all that?
Yeah, I had it actually today.
Today it happened? Okay.
Yeah.
But do you guys notice that that's because it's a certain hour in the day, because Miguel said in the morning, where that happens? Because I haven't had that problem as a user, but you guys have had that problem. Why do you think that's happening?
Well, maybe because a lot of people are on the app or the internet.
Yeah, that's a problem with information systems that has to be considered in the design. So the app, it's really not a problem of the app in itself. It's a problem that the app is going to require resources that have to do with connectivity, has to do with the amount of users that are using the app, probably at the same time, and that generates a bottleneck. Okay. Question: is that a design issue? Who thinks that's a design issue, or who thinks that's an analysis issue? So the app had to go through these 5 stages that we're mentioning before. The development of that app had to go through these 5 stages. So that situation that's happening in the morning, where everything's saturated, I'm curious, where do you guys think it's an issue? There's an issue in the stages.
I think it is in the schedule that there's too many people in like 7 a.m.
Well, I'm going to go back and rephrase the question again, Miguel. Let's focus on these 5 stages. So where do you guys think there's an issue that might have happened to get this solution? Also, I agree with you, Miguel. You're right, Miguel. But if I were to relate that to these 5 stages, where might the problem have occurred in the
In the
development of this?
testing, I think, because they should have got a test where what happens if there's a lot of people actually.
So that's a good observation, Miguel. I'm gonna go with you in a moment, Luis Gallardo. That's a good observation, Miguel. You say, well, you know what? The app might be correct, but maybe there should have been a test run under extreme conditions. That's a good observation, Miguel. That's a takeaway that I want to leave with you guys as engineers. We design systems usually for what I call a normal operation of the system or the process. We also need to consider scenarios which are extreme or problematic scenarios for the system. So the app is going to work if X amount of users are using. Well, what happens if for some reason we triple that amount or quadruple that amount or multiply it by 10? Is the app going to work the same way? So yeah, it's a good observation, Miguel. Maybe the testing should have been done differently. Okay, good. Luis Gallardo, what are you thinking?
I was going to say the same as Miguel about testing, but I also think it could be, in my opinion, it should be the problem in testing, but I think it also can be in deployment or implementation, because you design the app. For example, I think that was designed at the beginning for like this amount of people, or thinking this amount of people was going to school, but now they're letting more people in. They should implement the app and the development.
That's a good observation as well, Luis. So right now, Miguel and yourself, you say, well, the testing, yeah, it should have been done in the testing, but you're also saying, well, but also in the development and the design, maybe there was a certain perspective as to how it was going to work under what conditions. And maybe we needed to consider that there had to be an immediate scalability. So again, it's not the same that I'm going to be thinking about a system for 100 users if I'm thinking about a system for 1,000 users. Maybe the design of certain things is going to be the same, but the implementation or the capacity needs to be considered, and that's going to be different. And I think your observation is interesting as well, because I've always been thinking about this. You guys think about June of 2020. Everybody Let's turn on our cameras briefly. Turn on your cameras because I just want to see you and see your reactions. Think about August 2020 and be sincere in the question I'm going to ask you guys. Think about August of 2020. Okay. I said August. No, let's say June to bring it back a little bit. June of 2020. Turn on your cameras, guys. June of 2020. How many of you thought that, just do some reactions. How many of you thought in June of 2020 that in January of 2021, things were going to be normal and everybody was going to be back in the class? How many of you thought that? It's valid if you did. Did anybody think that in June of 2020, that in January of 2021, we were all going to be back? Luis thought that. Anybody else? Jesus? Fernando? By the way, that's fine. That's fine. This isn't a question that has a right or a wrong answer. I'm interested in your perspectives. Some of you did. I didn't. I was skeptical. I was one of the people that thought, you know what, this is not gonna work. 2021, we're still gonna be in trouble. Okay, let's fast forward. Miguel, you want to ask something? Go ahead. Or
Yeah,
comment.
I was having that same thought that maybe we could get back, maybe not. But then I saw like all the people going on vacation, and then I thought I lost hope.
Yeah, you started seeing what was happening, and you kind of projected that into a possible tendency, right? I was doing the same thing, and also looking at what was happening around the world. Another question: in January of 2021, how many of you thought that in January of 2022 we were going to be normal, back to normal? Anybody thought that? Luis, again, you're a positive guy. Jesus as well. I'm going to be frank with you guys. I shared Miguel's perspective, but I actually thought and was hoping that in 2022, we would be, in January of 2021, I was thinking that by January of 2022, we were going to be back to normal. Okay. By August of 2021, my perspective had changed. Why am I asking you? Why am I giving you this example? It has to do with what Luis was mentioning about the app. This app was not developed in January of 2022. This app started the development last year. And is it clear that perspectives are changing? Is it clear to everybody that perspectives are changing? Maybe somebody said, you know what, we're just going to need the app for 2021 and for these situations. And suddenly, situations changed. And now we're having more students getting in the morning, and that affects the app. So I'm going to argue that considerations should have been made since here. So I agree. I agree with a few of you commented about the testing. I agree. But I'm going to argue that in the analysis stage, certain things should have been considered, and that's what I call scenario planning, okay? And think about that as engineers, scenario planning. And I've actually given talks about this, and I was tasked in 2020 of the scenario planning committee at CETIS to kind of provide a perspective for the next year of how things were going to be. And basically in scenario planning, you have kind of this crystal ball, and you're trying, like Miguel said, you know what, I'm hopeful, but then I saw what was happening around, and I thought, nah, this isn't going to happen the way I thought. Sometimes when we do analysis, we're just focused on the current situation and problem. And we're not thinking about branches or possible multiverses, I'm going to say it this way, of situations that can happen in the future regarding the problem. And we don't take those into account. My argument when I'm doing the design of a system, I always try to incorporate scenario planning in the analysis part. And scenario planning means, yeah, right now I'm designing for this situation, but what if? What if? what if this other thing happens? You know what? Let's take that into account and let's incorporate something with regards to that. Okay. Scenario planning. So my argument is that, yes, the testing should have been done for different situations. And if we see a situation where there's saturation, we have to go back and do modifications. But I'm going to argue that since the analysis stage, my perspective is that it's prudent to consider these different situations. Okay. And why is that? Notice when I ask the question, I'm going to say that a third of the group is, I'm going to call the optimistic bunch. You guys are probably thinking things are going to be okay. Then there's probably another part of the group that's more the realistic or pessimistic bunch that's saying, you know what, I don't think things are going to happen this way. It's good to have both into consideration when we're doing the analysis. Okay. And yeah, good example there, Miguel. But I think you guys can think of a lot of examples of systems and processes where you interact with them as users and things don't go as you thought. Okay, questions or comments? Are we good up to this point? Does it make sense? Okay, let's. So yeah, good example that you guys gave about the Cetis app. So it's not necessarily that the app is wrong or badly designed or anything like that. It's just that maybe the situations or the use cases change, and so again, that's why I put forth that some things should be considered since the analysis stage and have this perspective of scenario planning for different situations that could occur further on, and always take into account in the design phase that the capacity, how many users are going to be interacting with the system, and the possibility of making the system scalable. That's important. And so the implications of a bad design is that there are many implications. We could lose information. There could be redundancy of the data, which wastes space. Something very important that has to do with inconsistency. We want consistency and reliability of the data. So updating, deleting or removing data or records, any of these operations can generate inconsistency. And that's gonna have our data not be reliable. I'm sorry. And that gives us a problem of data integrity. So the integrity of the data is going to be very important. It has to be reliable. It has to be accurate. It has to be available. All the things that we had mentioned previously. So for the purpose of this course and what we're going to be talking about right now, focused on databases, there's going to be certain steps or sub stages within the design stage that we're going to be following. First off, we're going to try to identify the entities now formally of our system and how they are related to each other. And that can be done through a graphical representation. And we're going to see that in information systems development, there's going to be graphical representations of the conceptual designs. And this is called the entity relationship diagram. We're going to learn how to do that. Based on that, we're going to create the relational model, which is basically the conceptual model as to how the different entities in our database and the data contained within them relate to each other. Based on that, we're also going to have to design what we're going to call forms. A form is basically going to be an interface with the user that helps us capture data to put into the database. And we're also going to have to design queries and reports. Queries are going to be these questions we're going to ask the database to extract data, package it, and then we're going to present it somehow as information. And that presentation of the information to the user is going to be what we're going to be, what's going to be called a report or reporting. Okay. Okay. What is an ER diagram or an entity relationship diagram? An entity relationship diagram is going to be the representation of a real world system or process or situation or problem. And it's going to have certain objects that we're going to be calling entities and how they relate to each other. And that those entities and those relationships come out of the analysis stage. And it's very important to have them well defined and well identified to be able to structure our database correctly. These can be represented graphically. There's going to be a graphic representation. It's going to be a kind of like a drawing that's going to tell us or help us represent all of these objects called entities that have to do with our database and how they relate to each other. And with that relational model, ER diagram, that's the basis of creating the conceptual solution that's the relational model for the database. Now, what do we need to know about an ER diagram? We need to talk about three things: entities, relationships, and attributes. And we had already talked about entities and attributes previously. We hadn't really talked about relationships yet. And now I want you guys to forget what you answered in the COVID-19 example, stage 1, when I asked about entities. Because again, you guys identified organizations, things that would interact, either providing information or requiring information from the information system or for the database. But we're going to give a more specific definition of entity. And I want you guys to start thinking about that for the next exercises we're going to be doing. So these are the more detailed steps. And we're going to be going through each of these steps. By the way, you guys are going to need to do these 6 steps from now on for the problems we're going to be doing, for the examples we're going to be doing and implementing, and for your application project, which we're going to be talking about shortly. So the first step in creating the conceptual model, the ER diagram, is to identify the entities in our system. Okay, so what is an entity? An entity is going to be a thing or an object that either has a physical or conceptual existence, meaning it can physically exist or it can conceptually exist. Okay, but it's there. It exists in the real world, and it has to do or is part of the context of our situation or problem. And the thing about entities is that when we define an entity, that entity has to be unique and identifiable and distinguishable from another entity or another thing or object. So these are unique in themselves. Entities have attributes. Attributes are going to be things that describe the entity and are going to be characteristics of the entity that help us understand it and describe it. So the example that's given here, let's assume that our information system has to do with a university. I'm not writing with the pen. I'm writing with the mouse, so that's why this is more ugly than my normal writing. The context of the system is the university. We're developing a database for the university. So if we think about a university, what could be entities under this concept or definition that would have to do with the university situation or system? Well, first off, a university, you guys would agree, is an organization that's very big. And I think we had given this example when we were talking about a university, and we're going to be developing a database or an information system for the university. We need to think about what that is for. So for example, if it's an information system or a database system that has to do with classes or the programming or scheduling of classes, then what would be the entities that are involved? Well, a student is an entity, or students are entities. Why? Because students take classes. You guys agree with that? A course is an entity because a class is represented by a course. So you guys take data analysis and organization. That's a course in your academic program, and courses are in academic programs. A professor. Why? Because a professor is going to be, or professors teach classes for students. So that's going to be an entity of this system. And classes are taught in a classroom. So this is going to be another entity. Okay. Are we good up to this point? These are entities of the system, of the situation, which is an information system for a university that has to do with class programming. We had mentioned in the previous, Leo, go ahead, please. Remember to turn
So
on your
in
camera.
the information system that we did from the COVID-19, what will be an entity?
Oh, we're gonna get there. We're gonna get there, Leo. And remember to turn on your cameras when you participate. We're gonna get there, but I'm gonna answer your question. One very clear entity for the COVID-19 as an example of an entity and you can name the entities in whatever way, Leo, just it has to be descriptive. I am going to call an example of an entity for the COVID-19 system a citizen. A citizen of Mexico is an example of an entity for the COVID-19 system. Would you agree with that, Leo?
Yep.
Because the system is to register the information, the COVID-19 information of Mexican nationals, of citizens. So a citizen is would be an example of an entity for that particular system. By the way, I'm calling it citizen. You could actually call it by many names. You could call it citizen. You could call it registrant. You could call them user if you want. But I think citizen would be descriptive of that. So that's an example. By the way, we're going to do this exercise for the COVID-19 system, Leo. Don't worry about that. Because we're going to be building upon that. But that's an example of an entity for the COVID-19. Leo's question is important. Right now, and because it's the next exercise that you're going to do, guys are going to do for next week, start thinking about other entities that have to do with the COVID-19 registration system. But let me go back to the university system. Let's say that, I think we had talked about this previously when we discussed this. But let's say that I'm going to write down some words here. Cars. Well, not cars. Vehicles. Vehicles. Would you guys agree that a university has vehicles? Does that make sense? We talked about that, remember? A university has vehicles associated to it. Does that make sense? A university has vehicles associated to it. What other, can somebody tell me what other things are in a university or are associated to a university?
Something that's associated with university could be classrooms.
Oh, it's all, that one is already there. So classroom, it's already identified as an entity for the context, but something else. Anything else? Think about could you say that again, Arturo?
A cafeteria.
For example, a cafeteria. Write that down. Just give me 1 second to connect the pen, the tablet here, because my mouse writing is really not as clear. Just give me a moment here. Cafeteria, that's a good example. Cafeteria or cafeterias, because there, Arturo, would you agree that there could be more than one cafeteria in the campus? There
Yeah.
actually is more than one cafeteria. So yeah, let's write that down. That was a good example. My writing is still bad, but it's quicker. Cafeterias. Good example, Arturo. Somebody else, other things that are in a university besides vehicles and cafeterias. You guys are the COVID-19 generation. You don't remember or know what things are in the school. What other things are in the school that you can think about? Fernanda, what comes to mind? Besides students, courses, professors, classrooms, vehicles, cafeterias, what else is in a school, or could be in a school, or related to a school?
Maybe offices.
Good example. Offices. Yeah, good example. Good, very good, Fernanda. Offices. For example, I want a couple more. Good example, Fernanda. A couple more. Give me somebody else. Give me a couple of more other things that we have in a university. Things that are. Arturo, go ahead.
Another example could be a gymnasium.
Gym or gyms. Yeah. Good example. Good examples. One more that anybody might come to mind.
The parking.
Parking. Good example. Parking. Good example. Parking. I'm gonna write it down as a parking lots. Good examples, you guys. I'm gonna this is where I'm going with this example. All of these could be entities. They fit. Do you guys agree that they fit the description of an entity? It's a thing or an object that has a physical or conceptual existence that differentiates themselves from other things. So these could be entities. However, here's the thing. The information system that I'm developing is an information system or a database that keeps track of the students and their classes, who teaches them, and where they're taught. That's what my information system is about with regards to a university. Are we clear up to this point? So now I'm going to ask Aimee, with regards to what I just said, a vehicle can be an entity, but does that entity make sense for the system that I just said I'm trying to develop? Does it make sense to include it? Yes or no, and why?
To me, no, because the vehicles goes into the parking lots.
So vehicles, I don't need to keep track of the vehicles for the context that I'm talking about that has to do. So for example, Aimee, if I want to know what classes you're taking or what classes you're enrolled in or where you're going to take them, do the vehicles that CETIS have anything to do with that? No, right? They don't. So vehicles, yes, it's an entity that has to do with the university, but it doesn't make sense for the context of my system. So why should I consider it? I don't. Alejandro, cafeterias. CETIS has, I don't, how many? 1, 2, 3 or 4 cafeterias. Would the cafeterias make sense? Or would I need to include that in my system? Yes, no, and why?
Yes, to keep track of their like food and ingredients they have.
Well, but I'm gonna go back to what I mentioned originally. The database I'm designing in the system has to do with your classes, Alejandro, what classes you're taking, who teaches them, and where you're taking them. In that sense, do I need information about the cafeterias and the food for that particular system?
No.
No. However, Alejandro, if I had changed the context and I would have told you this system, I need a database system that keeps track of the inventory and the sales of the cafeteria and which students are being, I'm still with you, Alejandro, if you can leave your camera on. I want to keep track of the inventory of the food and the sales and who it's being sold to, what students are being sold what food. In that context, would the cafeteria make sense?
Yes, because they are the ones who sell the food.
Correct. So what I'm getting at is that there can be a lot of entities with regards to a particular real life situation, but there are some that are clearly identified as part of the context of the problem. So for this context, the cafeteria doesn't make sense as an entity. Okay, good. Thank you, Alejandro. Anna, are you there?
Yes.
And I think if I'm not mistaken, you were the one that said offices.
No.
No, I heard somebody, but it didn't pop up. But well, Anna, I'm going to ask you, would the offices make sense in this context as an entity? Yes, no, and why? Do you think?
I don't think so, but maybe it could be because they're the ones in charge of like making the schedules and all of that.
Well, Anna, let's specify a little bit more of the context. When for the question I'm asking, when we're saying offices, we're meaning physically the office of a professor, for example. So I'm in office number 21 of building C, for example. Not departments, it's office, it's physically the office where I'm at. Do you think I should include that as one of the entities of the system I'm talking about, or not?
No.
Okay. Strictly speaking, no. I'm just interested in the students and where they're taking classes. I'm not that interested in the offices, but I'm going to put a note here for this one. I'm going to put a note here. I'm going to put this one in. I'm going to put a note here. I'm going to put this one as a question mark. Off the top of our heads, Anna, I agree with you. Offices wouldn't make sense. However, if I want to know where the professor should be located, and for that information to also be available, then maybe I could include offices so I know that Professor Sosa, that's teaching data analysis and organization, is in office 21. Maybe it might be useful, maybe not. It could depend on the analysis that we make. Off the top of our heads, this is probably not necessary. Thank you, Anna. Daniel. Daniel, are you there?
Yes, teacher.
I know the audio is a bit bad in the classroom, sorry about that.
Hi.
But the gymnasiums, the university has gymnasiums. For the system I'm talking about, particularly, that has to do with your classes, your professors, and where they're taught, do I need to include the gyms as an entity, do you think? Yes, no, or why?
I don't think so. For this case, no.
For this case, no. Now, something that I'm going to add a little bit, a twist here. Let's say that we're not at CETIS, but one of the academic programs that the university has is a physical education or physical therapy program. And maybe part of those classes are taught at the gym. Well, that's a bit of a different context. For this context right now, Cetis University, it really doesn't make sense for me to include this as an entity. But there might be a situation where they could. Okay, thank you, Daniel. Last but not least, Ivan, if you're there, Ivan, parking lots. Ivan, for this context that I'm talking about, would parking lots make sense or needed to be included? What do you
No,
think?
I don't think they need to be included.
I agree with you. Unless the system definition were different. I'm not interested. I'm also interested in seeing where you guys are going to be parking, because maybe I'm going to be charging a fee to have you guys have so maybe I can pay a fee for a parking lot, and maybe I want to know the capacity of that. Maybe I want to incorporate that. But right now, for what I'm talking about, parking lots don't really make sense. So I agree with you, Ivan. Thank you. So what I'm getting at here is that a university can have many entities, but we have to focus on the context of the problem we're talking about. Okay. And in that sense, we have to identify the entities that make sense for the system or the process or the situation that we're talking about. Okay. Questions up to this point? Are we good? Okay. Let's continue. And then we're going to define relationships. And a relationship is going to be an association that we're going to make between entities for any particular situation or instance. And sometimes relationships have attributes as well, not only entities. It's very important to identify and be clear about the relationship between entities. Maybe two entities can have more than one type of relationship between them. Okay, that's important. Maybe two entities can have more than one relationship to them. Or maybe an entity can have a relationship with itself. I'm going to see those situations as well. The relationships, eventually, we're going to put numbers to them, because relationships can be represented in many ways depending on the particular situation and how many instances can be created of the particular relationship and the entities associated to it. And so, for example, I'm going to put the whiteboard here. Just as an example, I'm going to keep with the example of the university. So the entities where students, I'm going to write them down just haphazardly here. Professors, put them in order, I think. Courses, and I think it was professors, and classrooms, I think it was. Let's do this exercise. And again, these are unstructured problems. Don't get too stressed, you guys. I'm going to ask you to think about the following. I'm going to give you a couple of minutes to think about it. Well, I have 4 entities here, and I want to establish the relationships between them. And the relationship is going to be, it's going to be very simple the way we're going to do it. I'm just going to connect. I'm going to connect these two. Notice the blue lines I'm drawing. The blue lines are going to represent relationships. By the way, I can draw as many lines as I want. I'm just going to draw those 4 from now, right now. The exercise I want you to do, and I'm going to be calling upon some of you, I want you to think of one word that I'm going to put here where I'm putting the question mark that describes how those two things are related. One word that I'm going to put there where the green question mark is, that is going to help me describe or understand how they are related. I'm going to literally give you 1 minute, give you guys 1 minute to think about that. And then I'm going to call upon you, or I'm going to ask for volunteers to help me fill in those green spaces. 1 minute. Okay, I think that's about enough time for you guys to think about it. Let's see, any volunteers? Can somebody give me one word that I can write down here between students and professors? Arturo, go ahead.
One word that can relate to both could it be school?
You said school, Arturo? Could you repeat that? Did you say school?
Yes, I said
Oh.
school, teacher.
Okay, let's do this exercise, Arturo. I'm going to write it down right now. The way we're going to interpret this is that I have to create a phrase that makes sense. So I'm gonna use the word you mentioned. So students, school, professors, or professors, school, students. Does that make sense?
I see what you mean now. No, it doesn't make sense.
Can you think about then, because I wasn't clear about that. We should be thinking about something that relates these two. And I'm gonna can you think about something there? And then I'm gonna go with you, Amy.
Yes, students learn from professors.
Okay, students, that's two words. But I'm gonna go with it. I gave you guys the exercise of one word just to make you guys think. It doesn't mean we can't use two words, but you mentioned students learn from. That's two words. I'm gonna allow it, but that makes sense, Arturo. Students learn from professors. Okay, that makes sense if I'm going this way. If I'm going this way. Okay. Good. Aime, you had raised your hand.
Yes, I think I will say students and professors.
Could you say that again? What is the word?
And
Students and? Well, But again, does the and represent a relationship? Is it describing what students do with professors or professors with students? It doesn't really describe the relationship, which is what we're looking for. Joel, go ahead.
And professors teach students.
That's good, Joel. If we're going this way, we can say professors teach students. That's a relationship. I'm gonna leave that. I'm gonna leave that there because that was a good one, and I'm gonna do it like this because it's important to understand how we're reading the relationship. So professors teach students. Good. Thank you, Joel. Good. The one that Arturo said, students learn from professors, that would be fine as well. We want one or maximum 2 words. We don't want a huge phrase because that's complicated. We want 1 or 2 words. Good. I'm gonna leave teach. Now, can somebody volunteer? Now, can somebody give me an example of a relationship between students and courses with 1 word?
Can it be take?
Take. Good. It's Leo, right?
Yes, teacher. Sorry,
Yeah,
I did.
it can be as simple as that, Leo, and that's fine. And I'm going to write students take courses. That's fine. That's a relationship. Another one that we could write here is students enroll in courses. That's 2 words, but that would also be valid. But if we leave take, that's fine. It's fine. Can somebody give me one here for professors and courses?
Thought.
Can you say that again, Leo?
Taught courses.
Taught or teach?
Teach, yeah.
Yep. Professors also teach courses. And that relationship would go like this. Arturo, go ahead.
This one might not correlate that much with professors and courses, but a thought I had is professors exercise their courses.
What do you mean by exercise? Just I'm not saying it's incorrect, just to be clear.
So like the professors like can exercise the courses or the students as well and exercise the courses they've been taught.
Oh, apply. You mean apply?
Oh yeah, apply.
Okay, yeah. However, apply is going to be a byproduct of the relationship. We might be able to fit that if maybe the course might have a project or something, and the application is through the project. We could do that relationship that way. So it could be a possibility there. Thank you, Arturo. Now, one that might be a little bit more complicated. Maybe we can't do it in just 1 word, by the way. What could I write down between courses and classrooms? Any ideas there? That might be a bit more complicated to assign with 1 word, but any thoughts there between courses and classrooms?
Teacher, what about partake?
Could you say that again?
Partake.
Partake?
Yes, partake.
Between courses and classrooms?
Yes.
Let's see if it makes sense. Is that what you partake? Courses partake classrooms, or classrooms partake courses? It sounds it sounds a bit forced there. Let's think about this, and it might be a bit difficult to do it in 1 word, but courses are assigned to classrooms. That could be, because a course is assigned to a classroom. And actually, this, this relationship between these two generates something that we talked about, that sometimes relationships create something else. This relationship in classroom terminology is what's called a group. Because the course assigned to a classroom is a specific group, meaning, for example, the data analysis and organization course, you guys can be taking it, and it's assigned to a classroom, that generates a group. But another industrial engineering that's not global program could also be taking that course, and that's a different group. Okay, so we're going to be doing these exercises where we're going to identify entities, and we're going to try to establish relationships between them. And these relationships are going to give us, in the end, the structure of the database. So for example, can somebody tell me something that's repeated there? That's duplicated? Teach, right? So I'm saying that professors teach courses and professors teach students. I'm going to argue the following. I don't need this relationship. Students take courses and professors teach courses. Students and professors are going to be related through this middle entity, which is the course in the group. So I don't necessarily need to say that professors teach students. I can say that professors teach courses and students are enrolled in the courses. And that way, these are related. And courses are assigned to classrooms. This is a very basic representation of what eventually we're going to be creating as an ER diagram. In an ER diagram, or entity relationship diagram, we're going to define all of the entities that we have, and we're going to see how they're related. And something else that we're going to do, that we're going to see how to do that systematically, is to establish what's called the cardinality of the relationships, which means how many instances of the entity are going to be involved in that relationship. And that's going to give us different situations as well. Okay. Questions up to this point with this example? No? Okay.